Hello and welcome to this presentation. Today we're going to be talking about multi-attribute simulation and specifically how VI-grade has combined the vehicle attributes of ride, handling, sound, and vibration into a single simulator to enable the experience of virtual prototypes in a complete and immersive manner. To set the stage, vehicle design and development engineers need to be able to experience the sound, vibration, ride and handling characteristics, and overall ride comfort to truly understand and assess the data they are measuring and the results they are receiving from their simulations. They need to be able to fully understand what all these numbers and plots and graphs mean in terms of subjective response and actual experience. They need to know what the vehicle will actually sound and feel like. Why? Because they need to make design decisions that directly contribute to the success or failure of the vehicle in the market, or which can affect millions of dollars of cost or profit, but they have no physical prototypes to actually drive and experience. They need to have confidence in their decisions to know that their design and content decisions are correct. This is where virtual prototypes and driving simulators come in. Ride comfort is a great example of a characteristic that is really comprised of multiple component attributes. Vehicle dynamics and NVH attributes combine and add up to the total experience of the driver or passenger in terms of motion, vibration, and sound. Before we dive into multi-attribute simulation too deeply, let's take a step back and look at the big picture. VI-grade has the purpose of accelerating innovation. Here we see the traditional approach to designing a new vehicle has been to dream it or get an idea and then make it or build a prototype and then try it, drive it, see how it works. A much more efficient approach is to try it before you build it. Eliminate the wasted time and cost of building multiple prototype iterations. Simulate and experience the results of the simulation in driving simulators first. Iterate much faster than previously possible with traditional approaches. This is the faster, easier, and safer approach to developing vehicles. Now, let's talk about experiential simulation. When you drive your car, you excite different frequencies and therefore experience motion, vibration, and sound all at the same time. Usually, these characteristics are studied and engineered separately. Usually, development activities are carried out separately on separate prototypes or using separate CAE simulation models. But it's not just about how the car handles or rides and what it sounds or feels like, but all of these things together. Ideally, you would experience all aspects of a vehicle simultaneously when driving a virtual prototype. When we talk about simulating vehicle dynamics, sound, and vibration together, we need to define and understand the frequency ranges involved. Sound, or the noise part of NVH, generally covers the range from 20 to 20 kHz. Vibration is typically considered to cover the range from about 5 to 150 Hz for the purpose of in-vehicle driver and passenger perception. Motion, the overall movement of the vehicle, is usually considered to be the 0 to 10 Hz range. Sound, vibration, and motion all interact and affect the overall perception of each other, especially in the overlap regions. The sound or noise portion of NVH has traditionally been treated separate from the vibration portion, with targets set independently. Likewise, vehicle dynamics, ride, and handling have typically been separated from sound and vibration. Again, especially in the overlap region, but not limited to this, there is a high degree of interaction, especially between what is considered ride quality and what is considered vibration. A simulator that could accurately represent vehicle motion, ride, and handling together with accurate vehicle vibration and sound to a level of fidelity sufficient for target setting, evaluation, and confident decision-making is the goal. As another viewpoint on the same concept, handling, ride, and ride comfort, vibration, and sound cover overlapping frequency ranges. From 0 to 5 Hz, the perception is primarily somatovestibular. From 5 to 30 Hz, this transitions to vestibular vibrational. From 10 to about 150 Hz is the range thought of and perceived as vibration. And spanning from 20 to 20 kHz, the ears perceive sound. Ideally, a professional driving simulator must provide a full spectrum frequency immersion, no matter what its final application is meant to be. When we look at how to build a multi-attribute simulator, it's useful to look at the various stages that comprise the overall experience. We start with handling, which is primarily 3 degrees of freedom up to approximately 15 Hz. This is the overall behavior of the vehicle. Next is ride, which comprises 6 degrees of freedom up to about 30 Hz. Overlapping this, and perceived more locally at the driver touchpoints, is vibration, which extends up to about 150 Hz. And on top of this, we have sound, which covers the range from 20 to 20 kHz. Now we can take a look at a single attribute simulator. The NVH desktop simulator is essentially a single attribute simulator focused on sound. This has a tremendous capability, and engineers can use this to design the right sound into their vehicle through comparing sounds, modifying sounds, and really understanding the sounds and the way the component parts of the sound add up to the whole. This type of NVH simulator is used extensively in the automotive industry to understand vehicle sound and develop the sound character of vehicles. But obviously, this is just sound. There is no vibration and no motion. Adding vibration to the sound adds a new dimension to the simulation. In this case, the static NVH simulator combines sound with multi-axial, calibrated vibration at all driver touchpoints. This is a very immersive simulation and could be considered to be a multi-attribute simulation, combining sound and vibration. Our compact NVH simulator has the same vibration plus sound capabilities as the static simulator, but in a much smaller footprint that can be easily accommodated in or close to the engineering office. Again, this provides the dual attribute simulation of sound and vibration to the design and development engineers. Now, let's look at what would be the ideal situation for a full spectrum multi-attribute simulator combining ride, handling, sound, and vibration aspects. We can look individually at each attribute and the inputs to the simulator. For handling, driver demand, vehicle velocity, and chassis accelerations are the primary components provided to and simulated by the simulator. Ride is primarily concentrated on the wheel hub accelerations and chassis accelerations. As we move to vibration, we are looking at wheel acceleration inputs, engine, motor, and driveline RPM as forcing functions coupled with vehicle response to these, together with the previous factors. And with sound, we are adding acoustic response to all of these. The important thing, however, is that these 4 attributes interact and affect one another. In a real vehicle, they are inseparable. In a simulator, in the past, we have typically focused on one or two of these, but never four together, like in a real vehicle. So we decided to combine all of these factors in a single simulator. The Compact FSS is the first real-time, driver-in-the-loop simulator to combine accurate motion, vibration, and sound in a single simulator. This is especially important when assessing virtual prototypes for things like ride comfort, where motion, vibration, and sound all combine into a single experience for the vehicle occupants. Similar to our other compact simulators, it starts with a carbon fiber chassis, which is optimized to be light and stiff for accurate response. The most noticeable feature of the Compact FSS are the legs. These provide roll, pitch, and vertical motion to the simulator to accurately reproduce the motions of the vehicle driving over various road surfaces. The legs provide the low-frequency motion and vibration. Movers are attached to the frame to provide fore-aft motion of the entire simulator. For high-frequency vibration, the seat is equipped with 3 shakers providing fore-aft, vertical, and lateral vibration at the seat base. Rubber mounts isolate the seat from the rest of the simulator. This design allows for the mounting of any seat to the simulator. Likewise, the steering system is equipped with 4 shakers to provide vertical and lateral high-frequency vibration to the driver. Accurate sound is provided through calibrated headphones by either VI SimSound or NVH simulator software. All of this is powered by an AutoHawk real-time computer to enable a complete, integrated, real-time motion, vibration, and sound experience. And all of this is contained within a small footprint, so it can be in or near the engineering office. We had the dream of combining the capabilities of our vehicle dynamics and NVH simulators into a single simulator to provide the best, most comprehensive multi-attribute simulation experience. And the Compact FSS is the first simulator to achieve this. This all-new Compact FSS simulator enables you to experience motion, vibration, and sound all together at the same time. It brings together the worlds of vehicle dynamics and NVH into a single simulator. This real-time, driver-in-the-loop simulator provides the motion, vibration, and sound needed to make design decisions with confidence in a small footprint that can be located in or near the engineering office. One of the applications that this is ideal for is ride comfort, where motion, vibration, and sound all combine into the overall perception of ride quality and comfort. This is sometimes also called vehicle refinement. Of course, one of the primary intents of this simulator is to be able to utilize various types of CAE simulation data to enable the experience of virtual prototypes, eliminating the need for most physical hardware. The Compact FSS lends itself well to seat comfort evaluation and tire evaluations, especially as they affect ride comfort and vehicle refinement. The most obvious feature of the Compact FSS is the motion system provided by the legs. The legs move the entire chassis of the simulator. Vibration shakers at the seat base provide fore-aft, lateral, and vertical vibration to the seat, and the steering system provides lateral and vertical vibration up to approximately 150 Hz. Sound is provided from the VI SimSound software or the VI-grade NVH simulator software. And the steering motor is the same steering motor used in all VI-grade compact, static, and full motion simulators. Additionally, the simulator can be equipped with an active seat and active belts, an active brake system, to provide additional cueing and context. Because of the design of the vibration system, vibration is delivered to the seat mounting bolt locations. This means that you can mount any seat you wish to the simulator and easily change seats. This is a real-time, driver-in-the-loop simulator, but of course it can also be used for fixed driving replay events. You may be wondering how all of this operates. What kind of model is used to provide information to and control this simulator? Here, we are combining two different technologies. For the motion, ride, handling, and low-frequency vibration, the standard VI-grade software stack, including VI Drive Sim and Car Real-Time, are used in conjunction with our standard AutoHawk real-time computer powered by Concurrent. For sound and vibration, we utilize the NVH software in the form of the VI-grade NVH simulator software, or VI SimSound, to provide sound and vibration synchronized to the motion. And the visual environment is provided by the VI World Sim software, generating a graphical environment or virtual world in track. The process starts with a scanned road surface combined with a tire model and multi-body model running in VI Car Real-Time, and this is combined with driver inputs, and that generates the response for the motion, vibration, and sound of the system. The Compact FSS is powered by an AutoHawk real-time PC for motion control and real-time vehicle dynamics, ride, and handling modeling calculations. A Windows PC provides the platform for the NVH simulator software, or SimSound, to provide sound and vibration completely synchronized with a real-time motion. VI-grade is well known for having an open environment, able to interact with a number of third-party software products and tools. Many of our customers already have processes and procedures built around various software products, and the VI-grade software makes it easy to incorporate and use these other software tools and products in real-time simulations. In addition to an open approach for software and running numerous third-party software solutions in the loop, VI-grade solutions enable an everything-in-the-loop approach, with capabilities for hardware in the loop, software in the loop, model in the loop, controllers in the loop, and just about anything else in the loop, including, of course, the driver in the loop as well. I have a short video that summarizes the new compact full spectrum simulator and all we've just discussed.
In today's fast-paced world of automotive design, decisions need to be made quickly and with confidence. But how can you have confidence in your design decisions without driving and experiencing physical prototypes? Introducing the Compact Full Spectrum Simulator by VI-grade, the ultimate tool for multi-attribute virtual prototyping. With the Compact FSS Simulator, engineers can experience primary ride motion, secondary ride motion, vibration, and sound all at once. This highly accurate simulation is powered by a VI-grade AutoHawk real-time computer running real-time vehicle models. But it's not just about the numbers and graphs. With the Compact FSS Simulator, you experience the full range of vehicle attributes. From the feeling of speed on the track to the comfort of the seats, the Compact FSS Simulator delivers a truly immersive experience. Get out of physical prototypes. Drive, feel, hear, and interact with your virtual prototypes in the Compact FSS Simulator. Experience, understand, and decide with confidence. The Compact FSS Simulator by VI-grade.
We recently held 2 launch events for the Compact FSS Multi-Attribute Simulator, where vehicle dynamics and NVH engineers were asked to drive and evaluate this new simulator. And I've captured some of their comments here. They said things like, "This is incredibly immersive. This is impressive. That the vibration together with the motion gives a great sense of speed and connection to the road. And that it feels like you're driving a real car," and so on. In conclusion, vehicle attributes like ride, handling, sound, and vibration cannot be fully understood from the plots, graphs, and numbers we get directly from simulations. These are valuable in themselves, but cannot be easily understood in human terms or in terms of how the customer will perceive them. So we need a way to translate those numbers, plots, and graphs into something we can feel, hear, and experience. In the past, vehicle dynamics and NVH have been developed independently, simulated independently. However, these two aspects of the vehicle very much influence each other when combined and experienced in a real car by the customer. With the new compact full spectrum simulator, multi-attribute simulation combining NVH and vehicle dynamics is now possible. You can now feel, hear, and experience all aspects adding up to ride comfort and vehicle refinement together in a single simulator at the same time. Combining these attributes creates an incredibly immersive experience and enables decisions to be made quickly and with confidence. Thank you very much for your attention. I would like to invite you to experience the compact full spectrum simulator for yourself at one of our sim centers. Just contact your local VI-grade sales engineer or visit vigrade.com for more information.